What is going on, YouTube? This is IPSEC, and we're going to be going on the defensive today because Hack the Box now released Sherlocks, and I Like To is the first one to retire. Sherlocks are investigative challenges geared towards blue teaming, and DFIR, which is, I think, digital forensics and incident response. And instead of just pwning boxes, we're going to be given boxes that have been pwned and have to do a bunch of analysis against it. We're not actually given the box itself. We're just given a lot of forensic files and, of course, a scenario. So let's go into this. The scenario here is move it. So hence the name, I like to move it, right? So there's been a box, move it has been compromised, and they've gathered some files, and when they did a memory dump of the server, they forgot to include the VMSS file, and that's going to prevent us from like opening the memory dump in Volatility and using all those plugins, which would be amazing, right? Because Volatility would be able to give us like screenshots, what programs are running. There's so many cool things we can get from Volatility. Unfortunately, we don't have it. We could click here to download it. I've already downloaded this. And then they gave a bunch of questions. So like name the ASPX web shell uploaded by the attacker, attacker's IP address, user agent, when the web shell was uploaded, what was the file size of it, what tool did the attacker use to initially enumerate the vulnerable server. And it does give kind of hints. We see it's 3 characters, ends in P. Enumeration tool is probably going to be nmap there. We could type it in and just take a guess. And we got that one correct. That's what it looks like. So we suspect the attacker may have changed the password for our service account. Please confirm the time this occurred. Which protocol did the attacker use to remote in? Another time. User agent used to access the web shell. What is the instance ID of the attacker? What command was run by the attacker to retrieve the web shell? What was the string within the title header of the web shell deployed by the threat actor? And what did the threat actor change the Moveit service account password to? So those are all the questions. I do have the Sherlock already downloaded. I just have it in C:/Sherlocks. We see the VMM file. If we go into triage, we have files here. I'm also on a Windows VM because there are some tools that just work better on Windows. And if you wanted to follow along, I just installed Windows and deployed this Flare VM. But to get things started, I don't know exactly how I'm going to structure it, or well, structure these videos because it's very different than what I'm used to, but we'll go along. I put all the questions as individual files here. And the reason why I did it is so we can link when we get data and our results or our notes. We can link it here and we'll be able to create a really cool mind map at the end. It's empty now because we don't have any links. If we unchecked orphans, you'd see everything here. But I haven't actually used Obsidian to do this. I haven't played fully through this challenge, taking notes and stuff. So I don't know what it's going to look like at the end. I'm really excited to see it. Where I'm going to start is what we have. Because all we're provided is a bunch of files. We have to identify what type of files we have. And to do that, I really hate just clicking around in GUIs, and I'm really familiar with like the Linux command line. So I'm going to load up Ubuntu on the WSL. I think that's Windows Subsystem for Linux. So I just have all my familiar tools here, even though I'm on Windows. So I'm just going to go into the Sherlocks directory, and let's make my cam a bit smaller. So now we can play. So we have this VMM file. If I run strings against it, it's just going to dump everything in the memory. Again, we don't have VMSS, so we can't use Volatility to do a lot of cool things like look at individual processes and things like that. So we'll see when we want to get to that VMM file. We do have a triage directory, and looking at it, the thing that sticks out is like request.json. Is this going to be like a proxy web server and we have all the HTTP requests? If we look at it, does not look like it. I mean, we have a lot of weird things and things that I don't think are installed on the server itself, right? So this is probably going to be some config of some tool that was ran to download things, right? These are probably all the supported programs it will extract forensic evidence to. I really don't know. I'm just taking a guess here. we went to like log.json, we see it is selecting the sans triage. So this is probably from some like sans playbook of extracting things. If we went into the results, we see everything is cape files. And if we did some search around cape files, this is going to be like, I think, an acquisition framework around just grabbing things. So I think all these files are created by Cape. Cape also created this uploads directory, I think, and put a bunch of files here. And it's just used like on a suspected compromised machine, run Cape against it, I think, to triage it. Don't know. So I'm going to skip it. And we're just going to go look at this upload directory. Right off the bat, I have a Moveit.sql. If I look at it, it looks like it is a MySQL dump. So under here, we'll say MySQL dump of Moveit. So we know we have that. Let's see, what else do we have? If we look in auto, we have like directories. We have a lot of stuff. So what I'm going to do is a find dash type F. So we list every file, and we can do a dash ls and call this files.out. Let's see if this works for us. And then if we do less dash s on files.out, now we can see everything. I did the dash ls because I also like seeing timestamps and file sizes, right? And we can see it ends with things. So what I'm going to do is grep everything that ends in log on files.out. And then let's see what we have. So we have Moveit transfer logs. So let's create a new thing, logs, Moveit. And then what else do we have? This inet pub log is probably going to be IIS access logs, I'm guessing. Let's look at it real quick. I can't do shift insert. Yeah, that is IIS logs. Okay. System 32. So we do have system 32 access. Let's see. Do we actually have config? Grep log config. We do. And look at the SAM file. That does have data. So I'm going to break a rule because whenever I get this, I always get excited and have to run secrets dump against it to get credentials, right? So we can do secretsdump.py. This is part of Impacket, so you can install Impacket if you don't have this. And then we specify, I want to say the SAM file, the security file, and then local. Is that enough? System. We probably didn't need the SAM. And these are all registry hives. And we can get, if we scroll up, oh, my history is not there. Wow. Pipe it over to less. There we go. We have a few credentials. So let's create a new file. I think Control N. Yep. 10. I'm doing credentials. And then I'm just going to paste all this here. I wonder if I do bash if it makes it pretty. No. And I have to move it over here. There we go. And the reason why I skip from 0 to 10 is just if I want to put things in between, it makes it easy and I don't have to rename everything, right? That's just generally how I do ordering. So we have a bunch of hashes. Let's see. AAD, that's blank. So I'm looking at the LM hashes right now. These are all blank. So we can't easily crack that. 31D6 is a blank NTLM hash. So these accounts are disabled. Most likely, I guess. Or let's see. Blank passwords, hope disabled. There we go. See, the Moveit service account. One was what did the attacker change? So I changed his password to. So we could probably go to like Hashcat and try to crack this password. I don't know that. And then 217E, this is going to be password 1 with like an @ and stuff. This I've seen this password hash so many times. I've recognized what password 1 is an NTLM for defer. I bet if we search this, watch. Google. I said Google, not Bing. Name that hash. Yeah, this is definitely used everywhere. Let's do crack station. Just search this one hash. that is password 1 or password exclamation point. So let's see. Under what we have, I'm going to put registry hives, dump creds. Okay. Oh, we also have the vmem file. No vmss. Okay. So let's see. I forget what blue screen of death dump files are. It's probably just .dmp, I would think. None of those. Maybe we should do a -i to make it insensitive. Maybe .dump. So I don't think we have any of those. If we did, then that's also things we could do analysis with because it's more memory dumps, and volatility would work with it. So what else do we want to look at? I'm going to look at EVTX, and I do that because those are going to be Windows event logs. So we have all of those. So we have IIS logs and Windows event logs. Let's look for like history files. See desktop.ini. Let's see. Console history. So this is PowerShell logs. PowerShell logs. Okay. That's good. And all this, I've always been out of that auto directory. We haven't really gone in NTFS. So I'm mainly going to look at that. And we have MFT. So this is going to be the master file table for the NTFS disk, which is just going to be like all the files on the host and some metadata around them. MFT. You could use a tool like MFT Explorer, but beware if you do, this is probably going to take over an hour to analyze the MFT file. It is definitely slow. So unfortunately, I have it closed, so I'm not going to bother. I want to do this video without cuts. So a quicker way that I like doing, I need to make that administrator. So I'm going to do Control Shift Enter, so we can run it as administrator. And I'm going to run a tool called MFTECmd. I think I have it on my desktop. MFTECmd. If we search this, it'll probably come right up on GitHub, Eric Zimmerman. It's this tool. So this will let us parse the MFT and put it into files. If you do it in a CSV format, there's a timeline program that's really good. Do they talk about it here? I forget what it's called. I think it's like Timeline Explorer. I generally use JSON because I like just doing things through JQ, grep, and things like that. So let's analyze this MFT. So let's do MFTECmd.exe-f, the file. It's going to be C:\Sherlocks, triage, NTFS, right? Or uploads. Yeah, triage, uploads, NTFS, and then what's the directory? Let's go back here. $MFT. Can I just do this? Is that going to work? We'll see. I'm going to do -H so I see all the options. I definitely wanted --JSON, and I'll do CSV as well. So we'll do JSON, C:\Sherlocks. Let's go mount, C, Sherlocks, make dir, analysis, make dir MFT. There we go. We'll do CSV to that same location, Sherlocks, analysis, MFT. So this will take still a little time to run. That's why I want to do it ahead of time. So when we get to it, we have the data. It's kind of like Nmap, right? Or any type of recon tool. You want something running in the background. When it comes to any type of forensics, you want like all the long running tasks or processing tasks just start at the beginning. So as you start familiarizing yourself, you know what's there, right? So let's see. Let's just start with thinking what questions we want to answer. So ASPX shell name, that's probably going to be IIS logs, right? And definitely attacker IP and things like that. So let's start looking at the IIS logs. So I'm going to go back into analysis. Oh no, triage uploads, grep inet pub on files.out, and let's go into this directory. Okay. So if we cat this file, we have a lot of data. And one of the things that's interesting is we have two IP addresses. We have this 10.10.0.25 and 10.255.254.3. If we went over to Google, let's see, IIS log format, there is, I think, this one that has information that's decent. Trying to find the exact post I liked. This log analyzer post is really good because it'll give appear as, and this string, all these strings are actually in our event log. So if we do a less against it, we see the fields. So we got date, time, SIP. If we look at SIP, that is the server IP address. There is CIP, which is the client IP address. So all that is good information. We could go right off the bat and look for that web shell, but that's generally not how I operate. I want to do just a lot of just analysis on this, right? So the first thing I want to do is filter out all the comments. So any line that begins with a comment, I don't want to see it. So I'm going to do a grep-v and then escape the comment on it. And now we don't have those. So now let's see. Let's get all the server IPs. So I'm going to do a awk, and then we're going to print 3. And now we have all the IP addresses that's server IP. We'll do a sort unique-c. We see there are 3 IPs. So I'm going to grab this, and then let's go over to our Obsidian. I'm going to call this 20 IIS logs. And then we can paste this. Okay, we get out of here. I don't like that it had like a whole line break. Oh well. I think it's just because my font is so big. So let's give it a header, and this will be IPs that are server IPs. Okay. So the next thing we want to do is probably client IPs. So let's do the same thing, except we want to count to the second IP address. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Awk print 9. There we go. And let's see. I'm just going to get rid of all that. There we go. That looks better. Okay. So I'm going to guess the attacker is either .2 or .3. But again, I don't want to jump the gun too much. I want to continue my analysis. One thing I did not do is say when the start time and end time of this log is. So I'm just going to say log range. And then let's tail this file and grab this. Okay. So let's see, we got the server IP, the client IP. I guess user agents would be good. So 1, 2, 3, 4, 5, 6, 7. I missed it. This was 9, and this is 10 then. So 10. We have user agents. Paste this. Okay. And looking at this, one of those user agents really sticks out. Well, a few of them. Ruby, Nmap, Linux. I'm going to guess the attacker's IP is whoever used Nmap, right? So let's grep Nmap on this. And we see it is 1055.254.3. So I'm going to go over to this, paste that, and then I'm going to link the file. So we'll just do a double bracket, 20 IIS logs, and then I'm going to do a caret, and we will say user agents, right? And we could also say nmap plus Ruby here. So now we have a decent log. And if we went to the mind map now, we would see the attacker IP question is linked to the IIS log. Maybe that's bigger for you, right? So that's kind of what I'm going at with how I'm organizing it with the questions. Okay, ASPX shell name, it specifies ASPX. So let's grep every file that ends in ASPX. Maybe it's -i. Oh, the lines don't end in ASPX, that's right. Let's see, that would be 1, 2, 3, 4, 5. So awk print 5. And then I'm just going to grep ASPX. We could do another sort. We probably should have done another sort afterwards. So in our notes, everything was ordered. Oh well. So one of these is a web shell. My first guess is going to be machine2.aspx. But what we could do is also join the IP address. That was, I think, 9? It was. So now we have the IP and the file. And we see machine 2 was only accessed by localhost. So let's just grep on 254.3 since that's the attacker's IP. And they've only accessed 3 files. Move.aspx, human.aspx, and guest access. If we looked at the exploit beforehand, let's do Moveit exploit analysis and looked at things. Mandiant has a post. Akame has a post. There are quite a few posts about it. It would say like the attack chain and everything. So I don't want to just spend all the video reading this. I would look at the logs and familiarize yourself with the attack or the hack the box machine, right? But the move.aspx is going to be what it is, or the web shell. Because if you look at other things, these files are referenced as Moveit files. So let's save this and say, do that. And then files accessed by the attacker. Go here, move.aspx. And then again, link it to the IIS logs. And it does put links here. You're free to delete them on these pages if you don't care about knowing the page linked. The link will stay active in the question and links here. So you don't need whatever it creates here. So we got the first two. We want the attacker user agent. I think it's the user agent that accessed the web shell, if I remember correctly. So let's just grep move.aspx on this log. And we're going to have this. Attacker user agent. And again, copy, paste it in here. UAs that accessed move.aspx. Okay. So now we're starting to make progress. Date attacker access something. Date of ASPX web shell. These I'm probably going to get the MFT, or at least the date of the ASPX web shell. Let's go back to the actual question on 4, because I did not take good notes on what that actually means. When was the ASPX uploaded? What is 5 then? File size. So this is file size. And I know there's no 6 here. I think 6 probably got deleted because it just goes 5 to 7. So let's see. I think we have a lot of stuff out of this. Actually, let's see. There was one more. Attacker user agent. Was that used to perform the initial attack? Oh, so this is wrong. The initial attack would be probably Ruby. If we look at IIS logs, you look at user agents, we see Ruby is 1. Whenever you see Ruby as a user agent, chances are it is metasploit. So we can see everything that Ruby is accessing. It's going to this DLL, then guest access, whatnot. So that is going to be Ruby. User agent, Ruby. Okay. And since we know it is Ruby, I would also go to Metasploit framework, GitHub, and look at the Moveit exploit. Let's see. Where is the file? Did they do like move underscore it? No. Wonder if we search the CVE then? Pull request. Let's see. Metasploit, Moveit, RB, GitHub. Is this exactly where I was? It is. There we go. So this is going to be the Moveit module. It's going to save this. Let's just go up a few directories. So that's 1, 2, 3, 4, 5, 6. Okay, that's a good place for tmux. Analysis curl -o Moveit metasploit module, because I'm going to want to analyze that in a little bit. Or we could look at it now, I guess, to see what it does. So let's see. Could not post. So the first request it's going to make against Moveit API.dll. I think. Here we're deleting things. We are doing an SQL injection to create a user. And we also have inst ID. So Metasploit sets the instant ID. So let's look at inst ID. Let's just grep it. Let's see. Update, move it. What if I do a -I? There we go. The instance ID is probably going to be 1234. So we can say 30 metasploit module. That's Ruby. Call this default. There's also like a normalize something. Normalize out of this. There we go. So this is going to be all the URLs it access. So it's going to go in API v1 folders, move it API.dll, API folders, guest access, token, whatnot. So I bet if we looked at the logs, we'd see it hitting all of these files, right? So let's go back to auto, find.grep inetpub, go into this directory, and then grep, was it 254.3 was the attacker's IP, I think? It was. So it probably accesses the DLL first, right? Or something. Let's just search for that DLL. So there it's accessing the DLL with Ruby. Then it goes to guest access. Then it does v1 token, folders, upload. And we see all of those here, right? They're not in that exact order, but all the URLs are there. So we know what it accesses. I can just put it here and say URLs and module, because that may be handy later, right? The instance ID, I'm going to put a question mark 1234 because this is just the default one. We don't know that. Metasploit would probably let us change that. So that's why I do the question mark, just so I have it there, right? Okay. I guess when we answer these questions, I should rename this probably. Rename. We'll just put a ZZ. So it goes to the bottom. We've done that one. User agent. Date accessed. User agent to access the web shell. So we already had that one. Metasploit modules, IIS logs. Files accessed. User agent. There we go. When, there we go. This is it. And we can link it. This is 20 IIS logs. Don't know what the title is. Files access UAs. There we go. Do ZZ. So we need the password, instance ID we think we have. When the attacker remotely accessed, let's go task 10. We don't know when they accessed the machine. That's probably going to be a Windows event log question, right? This is Windows event log. A lot of these are going to be Windows event log. Tool, enumerate, web server. That was Nmap, right? We saw Nmap in that. So we can do Nmap, and that's in IIS logs under user agents. So we've answered that. 04. When was the uploaded? We may be able to get it from the logs, right? Let's say grep upload on this. I don't see, it has file IDs. So this is probably going to be something we get out of the database or the MFT log file, right? Because we have that. We can just put it here. Okay. So let's look at event logs, I guess. That's going to be the next logical thing we do. So where is that? Grep evtx files.out. We are going into this directory. ls. I'm going to say export evt dir is equal to pwd. So now anytime I want to reference it, I can just do the variable instead of this super long path, right? CD dashes go into my previous directory. So I'm going to use a tool called Chainsaw. So if we do Chainsaw GitHub, this is generally how I parse logs now. It is really, really nice. So let's go into the analysis directory. Is it up one more? It is. Awesome. So I have Chainsaw in my path, and we could do, if we look at it, let's say we could probably just do -h. It has hunt with Sigma rules. We can search. We can just dump it. Hunting is pretty cool. I can show you real quick. So we could do chainsaw hunt. Then I want to say we need a -s in the Sigma directory. So I have that opt Sigma. The instructions for installing Chainsaw talk about where these directories are, right? Sigma is another repository. So you just do a git clone and clone that repository. The rules, that's going to be opt chainsaw rules. And then there is a -m for mapping. That's going to map the Sigma to groups, I think. And that's opt chainsaw mappings. And I probably should put these on multiple lines because I think my webcam is covering things, right? Or we can just do that to bring it up to the top. Sigma event logs all. Okay, so we did a hunt, we did the rules, we did the mappings. We can specify the out file, and when, oh, we need to specify the actual file. I think it's -f evt, what did I call that? evt dir? Echo evt dir. I did call that. So it's no -f. We just specify evt dir, and it's going to load every event log in this directory, which it's probably going to be a bit much and actually crashes because it couldn't parse this one log. So let's specify what log we want. We can do a ls evt dir grep for security, because I definitely want to look at that log. So we can do evt dir security.evtx, and then -out. We'll call this security .chainsaw, I guess. And it's not going to take too long to hunt. I don't think it will. There we go. It's done. I can exit that pane. It is outputting to the file now. Come on. I guess while this goes, I'll start the other thing I want to do, because I want to just get this log in JSON format. I'm going to guess I could type it now. I did not expect that to take so long. So let's see, we did chainsaw, and then we want to do a dump, and then the log file. So I'm just going to copy this because my variable is not in this pane. And we can say --JSON, and we'll call this security.json. Maybe we have to put --JSON before this. Unexpected argument. Chainsaw dump path. Wonder if it defaults. Oh, yeah, I wonder if it defaults to JSON maybe. -o security.json. So it's also dumping that. Maybe I'm going to pause the video and we'll resume when these dumps are finished. Something definitely odd happened there. Dump-h. Oh. We just specified --JSON. Okay. There we go. So yeah, I'm going to pause the video, let this chainsaw finish, and then we'll go over the results. So this has been going on probably about 10 minutes, and it's still not done. We did a tail-f on security.json. We can see it is definitely still writing to this log. So maybe I'm going to move all like my parsing event log stuff to the beginning. So it just parses like the MFT does, and then we'll have it when we want it, right? So I'm just going to put the event log stuff on the back burner, and let's look at the MFT while that processes. So if you remember, we generated this file with the MFT dump or MFTECmd.exe, and we have a CSV file, and there's like a timeline viewer program that really likes this CSV format. Let's see, less-s CSV. I don't like the CSV format. I find it hard for me to do a lot of searches, right? And if we used a GUI, yeah, that would be great. But the JSON format is really great as well. So if I do this.json, the main thing I'm looking for, let's just do a less-s, is that every JSON entry is on one line. So what that allows us to do is just grep for a file name in this MFT, and it's the master file table. So everything in NTFS is going to exist here. So I'm going to grep for what did we need to get? It was the file size of something, right? Date access, the file size of, is it the ASPX web shell or the ASP web shell? When was the ASPX uploaded ASP? So we need the timestamp of ASPX, date accessed, uploaded, ASPX, and file size of ASP. I made mistakes when I was doing that, right? That's correct. For when was, okay. So we want to look for, I think that was move.aspx. So I'm just going to grep for move.aspx on the JSON file, and there are 2 hits. So let's pipe this over to JQ. And I should have done a less. And this is going to show us the 2 files, or the 2 hits, right? This one's probably a file create. Let's see. File name. I don't know what the .compile name is. Maybe this is uploading to the tempter and then it moves it over. Let's see. When was this created? 11/24/43. 1124. Yeah, I don't know exactly what goes in there. Maybe it goes there when it gets executed. I can't make sense of that right now, but it was uploaded to www root. Let's see. It was created at this time. So let's go here. Control N, 40, MFT analysis. Let's put this up there. And let's see, we'll just grab the first one. And we don't need to pipe it to less. There we go. And that fits very nicely just on my screen. Move. Let's do bash like that. Or maybe, does it have JSON? It does. So this will be move.aspx. And let's grab this full timestamp. Go here. And this is 40 caret move ASPX. There we go. So we have a link straight to that forensic artifact. We can say that's now done. File size of the ASP web shell. If we look at the ASPX, it does have file size. Oh shoot, I did tail-1. Head-1. And it's slightly bigger. Do we have Xclip? Let's see. I wonder if Xclip's going to work in this. Let's install Xclip real quick. Come on. There we go. Xclip, selection, clipboard. Then let's go to MFT analysis. And paste. Sweet, it did work. That's the new move.aspx. And we did head-1. And we probably have to update the timestamp, right? Created and modified the same time. That is good. There we go. Okay, ASP web shell. So if we look, there was a file size. This is 1400. That other one had a very small file size. I forget what that was, but that's what tipped me off. I did the wrong thing. It was only 294. I'm like, what ASPX shell is that small? So let's just do move.asp now. Look at it. We got 2 hits as well. The second one, we see the file name down here. It's a .compiled thing. So I'm guessing that's just like when someone hits it, it's moveIt.asp. Let's see, it does have 2. This isn't going in that. I'm guessing ASPX, like when you access the ASPX file, it compiles in and puts it in that directory and then runs it or something. That's what the behavior looks like to me. Okay, so now we have this one. We have file size 1362 on both entries. Let's see, we think one may be a delete. So in use 1, file size, reference, timestamp, copied. I don't know what's different between the two. Copied false, copied true. So I don't know what the difference between the two is, but the size is 1362. And let's just grab the first entry, head-1, that's good. That's clip, selection, clipboard. Okay. And then we can say moveit.asp JSON. I'm guessing I clicked somewhere, it only highlighted one thing. Uh-oh. Oh, I have the head-1 after JQ dot. That's why I was only collecting that. So let's move head-1 there. Okay. File size 1362. Link it. There we go. And we've completed that question. So we need the password change, protocol used to attack remotely. So this is the event log data. Let's see if it's done yet. It is not done. So let's see. This is an event log question. This is event log question. Event log. I think this will be potentially the MySQL database. How the web shell was downloaded. Strings within the header. And password changed. Let's see, what do we have? Oh, we've now looked at PowerShell logs. So while we're waiting, again, a lot of this is just the art of being able to multitask, right? So where is console history? Console out of files, fix the typo. And we can grab this one. So we're looking at the administrator. And they've only ran NTStat. So that's not interesting. And I would probably take notes of that in my Obsidian notebook. But if I took notes of all like the things that aren't super interesting, but that I've looked at, this video would go many more hours, right? So here we have interesting things. So the Moveit readline. So 50 PowerShell. Put this here. Console history, Moveit. And this is PowerShell. There we go. They do a wget. And we also have the attacker's IP here. So if we had grepped all of our forensic evidence for 10.255.254.3, this would have also stood out eventually, right? So we have the wget command. Let's see. How was the web shell downloaded? With this. And this is 50 PowerShell console history. Moveit. There we go. So that's done. Let's see. Password. We did not see any password changes here. String within the header. We can say PowerShell and let's see. Interesting directories. So if we were cleaning it, we'd want to make sure these directories are off, right? Let's just do artifact directories or something. It's not a good name for it. We need to double backslash. And the other one was, that was inetpub, Moveit transfer. Okay. So we've got that one done. So we want to get the instance ID. And that's probably going to be through the MySQL dump, because when we're analyzing that metasploit script, the SQL injection put the instance ID of something there. So let us go to the MySQL file. Let's see, that was under analysis. No, triage, uploads, then moveit.sql. I probably should move the files to my analysis directory. So if we look at this, so MySQL dump, the easiest way is to spin up your own MySQL instance. So I think I have MariaDB installed. I think I just did a, let's see, install history grep install. I ran this command, sudo install MariaDB server, to stand that up, right? Let's do sudo systemctl start MySQL server. Is that it? MySQL, there we go. Sudo MySQL show databases, create database, move it, use move it. Let's see. Google.com, import MySQL dump. MySQL U. Okay. Sudo MySQL, move it, and then the dump file. There we go. So now if I do sudo MySQL, use move it, show tables, we have everything here. I think it was under log that we want. So if we did select star from log, shoot. So if you didn't know, if you do the semicolon, it's going to output like to the screen. And when you select a lot of data, it looks bad. If you do \G, it's going to output in like this format, which is good. So we probably want, let's see. I want the time. Let's see. I definitely want time. That's log time. Then inst ID, username, IP address, file name, folder path. That may be good. So let's select those. So if I grab this, paste, awesome. So we can see, I guess 3 instance IDs, 0, 36, 36, and 1, 2, 3, 4. They're all from our IP address. I'm guessing it is 1, 2, 3, 4. It could be 36, 36, but this is actually authenticating with these credentials, I think. Let's see, is there an action? I wonder if I should have grabbed action. I think action was also 1. Yeah. So those are sign on. This is message post. I wish it said like file upload. That is session ID 0. But okay. So let's say into out file mount C Sherlocks analysis MySQL.dump, where we'll do interesting logs of MySQL DB. There we go. So I just put a single quote semicolon there. And I think it saved it there. Analysis. It did. That is a weird file name. Let's see. How do I reference that 1? I honestly do not know. Did I delete it? It did. Awesome. So let's grab 1, 2, 3, 4 from this. And we can just copy and paste this. So this will be 60 MySQL DB. Okay. Instance ID 1, 2, 3, 4, and we can also link 60. We did not title it. Logs table. There we go. So now that one's linked to 2 different things. ZZ. Okay. What password he changed it to. We could also link this to credentials, because we do have the NTLM hash here. We just don't know what it goes to, right? Let's see, string header. Is there event log done yet? Exit that. It is still dumping. I swear it didn't take this long when I was testing things out. What did I change? CD. So we did chainsaw dump. The event log. Yeah. I guess it just takes a long time. How big is it? 18 megs. How big is the event log? 21 megs. So hopefully it's close to being done. I'm assuming the event log format is compressed and this JSON isn't, so it would be slightly bigger. But I guess we could look at the other output while we wait. So this is the one when I did the hunt and Sigma. I probably have it in my history, right? Hunt. So it's going to be the output of this. So we did hunt, specified the Sigma, specified the rules, specified the mappings. So what that creates is this fancy thing. Dash SSB before the file name. And there we go. And it has groups of just activities and shows activities around that, right? So we can see Moveit service was created June 13th. I think the attacker was in July. So this is just them installing the Moveit service. We can see them adding the user to the group, probably added it to administrators there. We got another, what? 613-1553. So it creates the user twice. That's weird. I wonder if they deleted the user somewhere and then reinstalled it. It's odd. We don't see a password change, so we don't know that. And then we have this lateral movement thing. Network logons. And let's see. I forget exactly what login types are. I think 10 is interactive. 3, let's see. Let's just Google this. Windows event log, logon type. That sucks. What is 3, 10, and whatnot? Hoping. Okay, here we go. So 3 is a network login. 10 is remote interactive. So these are all network logins. The IP address is 10.10.14.6. Then we have 10.10.14.13. I bet this is like PS exec or something. So those are all in June. Our attacker wasn't on the box in June. I think it was, let's see. date uploaded to ASPX. This is July, right? So all these are benign probably, unless there's two attackers. But we do have an RDP login. So one of those questions, protocol used, RDP, and let's see, IIS logs. I'm going to do a 25 PowerShell logs because I want my logs to be next to each other. So again, that's why I do that incrementing thing, because when I'm like, I want to put something there, that becomes so much easier. So let's see, do I have flame shot? I should have it. Let's just do that. Run. Screenshot this. And we'll name this security.chainsaw RDP login. That should be fine. I did a paste image there because like copy and paste doesn't work well with this, I don't think. Like if yeah. So that's why I defaulted to a screenshot there. Okay. What was it? Protocol. This is 25. There we go. Password change. So that's going to be event log 4724. 4724 on this. What? Event code 4724. Account attempts, yeah. Password reset. Okay, I guess it's just not in this log. It'll probably be in this giant JSON dump whenever it finishes. .json, 22 megs now. Let's see. And it's not just on one line. If it was on one line, I would just copy this log file off and then I could start analyzing with JQ, but it ends with invalid JSON. So that'll make JQ very unhappy. Is that the only thing I have? What password the attacker changed the Moveit service to? I guess now we could go in the memory dump. So if we do strings, I like to move it, and let's grep for Moveit SVC. Let's see, is there anything? Actually, I'm going to put a space before and after because they're probably changing the password with like net user, right? So if I add that space, hopefully that will be enough to just find it. And if it doesn't find it, then I'm going to change the encoding. Strings has a few encoding options. I think it's E, L, and B. Let's see. What is dash E? SBL. I forget exactly what they are. It's just like the endianness of things. So if we do strings dash E B, I'm on uploads. Strings dash E B. Does this get anything? It's not really. It's getting stuff, but it's not just text like we saw before. I bet my hard drive because I'm recording the video, maybe there's a lot of I/O to my hard drive and that's why this is going slow. That, I guess, is my best guess right now. Because it shouldn't take this long to do strings. So right now we're just looking at Moveit service. And if this was a domain and we had the ntds.dit, when we did secrets dump a long time ago, we could have done the, I think there's a option for it. Secrets dump.py-h, a password last set and a history. That would have told us that as well, but that queries like LDAP data or something, and we don't have that because it's not part of a domain. So I'm just going to wait for these two commands to finish. So I'm going to pause the video, and hopefully that speeds this up. Okay, that chainsaw is finally finished, so we have the security logs. So before we get to looking at that, I'm just going to grab the strings of this vmem, and we're just going to put in analysis and do strings.vmem. So that will probably speed up some time later on. So let's go take a look at these, the security.json file. It is 36 megs, so it's almost double the size when we convert it over to JSON. But now this is going to be a lot easier for us to just search through. The downside is it's in multi-line format, so we can't just like grep an entry, then pipe it to JQ. If we do greps, we have to dig down in this. So let's see. It's probably going to be easier if I go to a new pane to show this. So we want to go back into analysis. And let's split the screen. Okay. So if we look at this, we're going to want to go into event data, event data, and then we wanted 4724 was the event ID we wanted for password change. So we want to grab those events. So let's go JQ, and then we have to do the open closed bracket because we're in a list or whatever they call that. And then we can pipe it over to a select statement, and we just do event.system.eventID is equal to 4724. I think I just end that JQ. Let's see. Oh, we got to give it the file name. Let's see. That did not like it. There we go. And nothing. Oh, we have a typo. We have 3724. So 4724. And it's going to search this JSON file and print everything out. Now, the issue is we have a lot of data here. We only want to get certain amount, like certain fields. The fields I'm going to grab are going to be target username, the subject username, and let's get a timestamp. This timestamp. So we want 3 fields out of this. The subject username is going to be who is changing the account. The target is who it is going to be against. So what we do is just another pipe, and then we can do a bracket. And then what we do in the bracket is call the field what we want. So the first one I'm going to do is time, and then we do a colon, and then drill down to what it is. So it was a .event, I want to say. Event. It's not event data, it's in system. So event.system. What is it? Time created, attributes, and then system time. So I'll put that at the top so you can see everything. We'll close that bracket off. And now when I run this, it should only tell me the time. So now let's get the other fields we wanted. So event data, subject username, and target username. So we can grab those. So let's do, I guess we'll call it subject and target would be the most logical. So event data, subject username. And then we wanted the target, which is going to be the same thing, but target username. So now when we run this, we have nice data. So let's see. It is showing some things where the target is not what we want. So like the target is defer, we don't really care about that. So let's filter on that. And to filter, we can go all the way up where we have this event code and then do an and then we say event data dot subject, oh no, we want target user name is equal to Moveit SVC. It's going to take a second to run, and there we go. We have the query. It is not sorted by time. The way I generally do this will be I'll do a second JQ, and what we will have to do is a -s, which is I think they call slurp, because we want to make this into a list. This is just a bunch of single items. If we did a -s, that is going to put those brackets around it, and it creates this nice list. So because it's in that list, that will allow us now to do a sort underscore by, and then just time. I think that's it. We just need a period before time. Sort by could not open. Maybe we don't do the period. There we go. So now it's sorted by time. This is every time the Moveit service password has changed, and we can see the attacker was on the box July 12th, we know, and that is when it changed. It's also the only time Moveit changed its own password. Every other time it looks like administrator is changing it. So let us copy this query. We can go back to here. Let's see, where is our event log? PowerShell logs. We don't have one, so we can create one. And I'm going to call this 22 event logs security. We can't use a colon. And then let's pretty up this JQ command. So we can do that, select that. That looks good. There's no way to fit this because our screen is so big, or a font. Subject, target. Good enough. So now let's just get that data in. We can just copy this and then paste it. Awesome. So we have the time of the password change, and then we link it to 22. And we don't have a title on our log. 22. We will call this Moveit PW changes. There we go. Awesome. That's done. When the attacker remotely accessed, that was in the RDP. We had that somewhere. Was that? Let's see. Where do we answer that? It was in the screenshot. Here it is. Well, we have credentials. I don't know where we pasted that. Let's see. It's the protocol. PowerShell logs, we linked it. That's not right. That should be... That was the console history. Whoops. We screwed up a lot of the logs. So this is event logs. Call it security and hunt. Update the link. And then let's just type this timestamp 07 12 11 11 18. Okay. So when was remotely accessed, there we go. Awesome. And we are almost done. We have string and the password. So this stuff we'll have to carve out of the memory dump. So hopefully that strings command is done. It is. So if we go into analysis, du-hs strings.vmem, 251 megs. So let's grep Moveit svc out of this. We have a lot. Let's see. I see it right now. We have it there. But what I probably would have done is a sort-u, because we see this string just coming a lot, right? We did wc-l, let's see, 1600 lines, sort-u, and 113. So doing that sort-u really helps. So I'm going to do a unique-c after that. And then we can sort-n. And this may help us a little bit. So where was that net user? Here it is. Grab it. Do we have a memory dump? I don't see one. 70 memory dump. Let's see. It's in there. That's fine. Net user command. I should put my command here. Like that. There we go. I did this dot so I know I like truncated the output, right? So we have that. This is what the password is. And then we can also link the memory dump. Go to the section. Okay. And the final question, string within the title header of the web shell. I'm going to go back to the questions because is it the ASP or ASPX web shell? There are two web shells within the header of the web shell. I guess we'll try the ASPX first. So let's grep move.aspx on strings vmem. And then we can do a -b 20 and -a 20. And that grabbed before and after. So whenever we see moveit.text, we'll grab 20 before and 20 after. I'm going to search for title. And I think we have it here. Right there. So we will put this. Bash. What was that command? That. Okay. Awesome. And this will be move ASPX web shell and add Z's there. And of course, we link it, right? Memory dump. There we go. Okay. And that should be all the questions. There is one thing I want to do before we just wrap up this video. There is one log I always like looking at that we just forgot about because it took so long to do the previous security logs. If I wasn't going for the questions, I would always look at this log. I think it's triage uploads, find.grep evtx, grep-i defender. Defender is another great log to look at. We have it here. Let's just go into this directory. Get out of the file. Okay, ls, we'll just copy it. So we can say export def log is equal to our path. And then we will grab the operational log. Do we have to put quotes around it? Echo def log. Awesome. So let's go back to our analysis directory. Mount C Sherlocks. Analysis. And then a chainsaw command. So we can do chainsaw. I guess we can do the hunt first. So we'll do hunt, the sigma, opt sigma rules, opt chainsaw rules, and then the mapping, opt chainsaw, mapping sigma event all, and then the event log -o, and we'll call this defender.chainsaw. And this shouldn't take too long. Let's see, log path is invalid. Shoot. Echo def log. Maybe we put this in double quotes. There we go. So now it is processing that, and we'll get defenders logs. You can also do a JSON dump of this as well. Doesn't really get us much more information than what we'll have. Let's see. Can we just look at the analysis file while it's going? Defender chainsaw. We should do a -s. And these that are empty, eventually, I guess it's at the very bottom, we'll see Defender being triggered. And we'll understand why they switched over to the ASPX shell, because I think Defender removes the ASP shell. So it detected that, right? So that is something we should always be looking at whenever we have these, is also the Defender logs. So hopefully that finishes soon. I really got to look at like putting my recording on a different hard drive than my VM, because that is slowing this down tremendously. Let's see. We're not in July yet. We're on November 10th. I think it's July 2023 is when the attacker is in. So that's June now. It's getting close. If we did a tail-f, we'd see like the output streaming to the console. But I'm just going to pause the video. We're going to wait for that to finish. So it is now done. So now if I do that less dash s on defender.chainsaw, and we go to the bottom. Man, maybe I want to do the JSON dump because this gets ugly in this bracket. But we can see the alerts. Let's see. Will that work fast? Let's see. We just get rid of that. Get rid of all of this. Dump. Dash dash JSON dash O defender.json. So generally I use this to do a first glance at the log because it's good at highlighting what I should be looking at. And then I generally go over to the JSON and look at it there because it'll be a lot cleaner of an output than this is, right? Let's see, action ID 9. So this is remove suspicious behavior, completed successfully. This is on IIS.exe. Let's just search for move.asp. Let's see, moveit.asp. And we see it here. So this is Defender cleaning that up. It says it's a backdoor. It detected from the user moveit svc. There's the engine. The path c:/inetpub www root moveit.asp. The process name, so this was PowerShell. I think this was the wget and the console history. And that's the thing I screwed up here. We don't have console history here, but that is the log, right? And we're still waiting on the JSON output. Let's see, du-hs, defender.json, 832K. I guess it'll be finished somewhat soon. So yeah, let's just click on the mind map real quick and see what this looks like. So this is just a graph of how we get to all the questions and the files. And we'll see some of them are linked, like this IIS log. We can see all the questions this guy answers, right? So I think this is a pretty cool thing. Event log, security hunt. We answered 2 questions there. PowerShell. Oh, we do have the console history on 50. Yep, that's where we put it. So yeah, that pretty much wraps up the video. I just wish this one thing would finish so we can show you exactly how it looks in the JSON output. So I guess I'll let that finish. We'll pause the video, resume when it's done, look at that, and wrap up. Okay, the Defender log is now parsed. So if we did a JQ on the Defender log, pipe it over to less, then we just go to move it. Let's see, let's say move it dot, oh, we have it right here. So we can see all the data we saw in the previous one. It's just in a bit of a better format. I wonder if we did -s, does it? I wish it kept the syntax highlighting. Let's see, let's just do, we just do v defender.json. There we go. Move it.asp. So I think this is a bit easier to read than the other format. We could probably filter by action ID 9, but and also Google to see exactly what action ID is. It's just a bit easier to read, and we can see it's concrete, so it's positive this is a virus. We have the process name. If we had sysmon logs, we could probably look at the process ID and trigger like the parent process to see what spawned PowerShell. It would probably be IIS since we know what's going on, but this is all the types of things I would be looking at. So with that being said, that's going to be the video. Hope you guys enjoyed the first video on Sherlocks. Let me know in the comments below if there's anything you didn't like or you'd want to see more, how this whole thing is organized, if I should keep Obsidian and keep going down this path. Of course, let me know. So take care, guys, and I'll see you all next time.